Well, after that introduction, there's nowhere to go but down. Um, I want to thank Jimmy for the opportunity to address you guys. This is always a pleasure to talk to you guys, one of the most active archaeological societies in the state. And when Jimmy invited me to give a presentation, I thought about a number of things that were possible, but the one that I'm going to talk about tonight is a little strange. It's a subject that many of you are probably not much aware of. They are enigmatic, strange little landforms that occur all over the place in eastern half of the state of Texas. And I first had an encounter with these things early in my career when I was a graduate student. The very first archaeological site I got to work on was on one of these mounds. And I hadn't seen many of them for most of my career until this year. And then this year I've worked on several sites that had Mima mounds. So I thought this might be kind of an interesting time to talk about it because some of the things I've seen in the last year have kind of changed my perspective on the kind of context and integrity of sites that occur in these mounds. So if you live in North Texas, you are, depending on where you live, you may be surrounded by these features. They are, I sometimes like to think of them as crypto landforms. They're small. They're what are referred to as microtopography. And these mounds they're not very big. They rarely get over 1 meter in height. They typically are somewhere between 10 and 50 meters in diameter. And usually if you see one, there are going to be oodles of them. They're everywhere. But to give you an idea of how crypto they are, this is an aerial photograph from one of the areas we'll be talking about today. This is up in Fannin County. And this is an area that we drive by all the time going to one of our sites. And you can look at that aerial photograph and not really see much evidence of any kind of variable topography. But if you look at a LiDAR image of the same place, it is a completely different story. And all of those little bumps that you're looking at on that image there, which is a LiDAR digital elevation model, shaded relief image, are Mima mounds. And in this landscape, if you go back, I'm going to toggle back and forth, some of the more impressive ones are in the top right corner in a landscape that I think is probably has never been forested. And they have some of these beautifully large mounds that are just, you can't even tell they're there when they're in the forest. But you can also see in this image lots of mounds that have experienced a lot of historic transformation. So if you go over, I don't know if you can see my cursor in the top left side, you see a field here where mounds have been plowed down, and you can see how they're getting smeared by the plow. And so in some places in this area, like this big parcel kind of in the middle to the west of this forested tract, barely has any mounds on it visible today, but those have mostly been plowed down by historic agriculture. So these mounds were omnipresent in large places in Texas. And they occur across Western North America. They are very widespread. And one of the weird things about them, you'll notice from this map is you'll notice they don't cross the Mississippi River, which is perhaps very telling about their origin, which we'll come back to later on. But they are principally a Western North American phenomenon, but landforms like these features occur globally, and they've been the subject of considerable debate for a very long time. Now, what you want to call these mounds depends on where you live and where you are. The term Mima mound is the name they use in the geomorphological literature these days, and they're named after a prairie in the state of Washington. It's called the Mima Prairie. But in the literature, they go by all sorts of different names. There's a book that I'll point you to if you want to read some more stuff about this later on, that actually has in their appendix, what are all some of the names that they call these mounds? And so they start off, we in Texas have this lovely evocative term, the Pimple mound. That's a really nice name. Some places they call them prairie mounds. Some places they're called vernal pools. Others they called them blister-like mounds. So there are some people competing for our Texas lovely name for these features. Some places they've been called fish mounds. My favorite, of course, is heaps of confusion, which I think actually still works pretty well today. Marsh mounds, gas mounds, there are lots of different names they go by. And some odd facts, there are over 100 proposed formation processes for what creates these features and over the last century. Some of these are much more fanciful than others. My personal favorite was the glacial geologist that in the late 19th, early 20th century, Luis Agassiz, who was a very big name in geomorphology. His personal favorite was he thought they were mega fish burrows. Long story involved there. But nevertheless, I thought that was a really creative one. A lot of people mistake them for built earthen mounds made by people. And indeed, they're often very difficult to tell if that's what they are or not until you cut into them. Over the last, I'll say 30 years though, people in geomorphology have kind of reduced the number of possible formation processes to principally four. And those four are differential erosion by water, freeze-thaw activity, sometimes called periglacial activity. So in landscapes where the temperature fluctuates back and forth across the freezing point, the development of needle ice in the dirt creates all sorts of weird things. And there's a whole classification of strange geomorphological features that are called pattern ground that just are kind of really psychedelic looking things. And Mima Mounds are right in line with some of those possible features. Another one is aeolian sedimentation. Some people think they're sand dunes. And perversely, the last hypothesis is bioturbation, the mixing of soil by animals, specifically mammals that live in the soil. And at this point in time, it's my opinion, there's hardly a universally accepted hypothesis for how they're forming. But the hypothesis that seems to be gaining most ground and most traction is that these are features that are created inadvertently by animals like gophers, who live in small groups, and when they forage away from their home, they're always pushing dirt back towards their home. And the long-term effect of that is that it creates a mound. But the challenge in trying to understand how these mounds or how these landforms are created, it can be much more challenging than it might sound. So in geomorphology, when we look at landforms, we often find that many landforms, we're trying in this case to identify the source of the topography, what created the mound itself. And in a lot of cases, the mound or a landform comes with a body of sediment. So think about a sand dune. The sand dune, the sand comes and creates the dune, and therefore the dune and the sand are actually part and parcel of a single event. But the one that's more challenging to think about is, what if the sediment that is comprising the mound was already there and something just mounded it up? How do you demonstrate that? And that turns out to be an extremely challenging, thorny issue. And it's one of the reasons why this is still kind of a somewhat debated subject in geomorphology. So if you want to go and look at a book that actually has some information on this and covers a lot of ground in terms of the formation processes and what's been postulated in the past, this is a book that was published almost 10 years ago now. It's a collection of edited papers that was published by the Geological Society of America, and it basically it's called Mima Mounds, the Case for Polygenesis and Bioturbation. The second editor of this, Donald Johnson, was a geomorphologist who spent much of his career studying the effects of animals and plants and things on soil and how they affect it. So anyway, if you want to read more, that would be what I would point you towards. But why am I talking about them here? You're starting to ask yourself, because it's like, this is hardly archaeology, Charles. Well, one of the reasons that I'm talking about it here is because these landforms are common in Texas. Ponder, if you will, that the coastal plain of Texas in the early half of the 20th century and in the 19th century was referred to as the Pimple Prairie, the entire Texas coastal plain. So they were prevalent everywhere. And not only were they all over the place, they were preferred places of prehistoric habitation. But in the landscapes where they occur, not all mounds were occupied. But some of the reasons that I want to talk about them is because we often find sites in these mounds, but why? And what kind of integrity do they have? Well, the why of it is fairly straightforward. In many of the landscapes in which these mounds occur, they live and occur in landscapes that are seasonally wet. And in certain times of the year, there are only dry ground in these landscapes. I'll give you an example of this. This is one of the more spectacular Mima Mound landscapes I'm aware of in Texas. This is Smith Point on the east side of Galveston Bay. This is a barrier island like Galveston Island that dates from about 65 to about 85,000 years ago. It's called the Ingleside Barrier. And it has some of the most spectacular Mima Mounds I know of. And you can see from this image that some of them are discrete round features. Some of them kind of form chains. When you get around a body of water, they actually form almost continuous rims around the bodies of water. And, but in this photo, what you're seeing on the bottom right is coastal marsh. And the elevation in this landscape gets progressively higher to the top left of that image. Well, if we look at a little bit different image, this is from 1943, but if you look at a slightly different image, This is, you can see in this image, this in the bottom, on the left half, you can see that kind of light color image. I'm gonna put my cursor over this area in here. You can see that that's water reflecting off of, or I should say light reflecting off of water between the mounds in this area over here. And all of this area along the bottom half of the image, all these mounds are submerged in water. So this is a period probably soon after a tropical storm or during a high tide, but this is a landscape where these are the only dry ground in this landscape at certain times of the year. And so if you're living in this landscape and you want to exploit the resources that are prevalent nearby, you're gonna live on the mound. Simple as that. So what I want to talk about in this presentation though is some of the things that have kind of come to my attention here in the not too distant past. And these are observations on somewhat on the age of the mounds and on the context of the sites that occur in these mounds. And in particular, I'm going to focus on something that probably is not on most of your radar, and that is how animals mix and can disturb our sites, a process called pedoturbation. Pedo meaning soil and turbation meaning to mix. And up until kind of this year, I more or less thought that these processes were more or less the same everywhere. And it's in the last year, this has become glaringly obvious to me that that is not the case. And where these processes differ has a real knock-on effect in terms of the context and the integrity of the archaeology that we find in some of these sites. So one of the agents I'll be talking about in this talk is on view here on the right side of the screen. This is the action of a pocket gopher, one particularly miffed pocket gopher who was perturbed that we have the wherewithal to stick a hole through his house. And so you all, if you've been digging for any time in Texas, you've probably had this experience where you have one of these guys trying to backfill your unit for you on a fairly regular basis. And they, as you can just tell from this little short time lapse, which was about a 3-minute period, they can move a tremendous amount of dirt in a relatively short period of time. Notice also, he's moving it sideways. Well, it's going down after it comes out of his hole, but he's pushing it around sideways. And so not all the movement of the dirt by these gophers is up and down. A lot of it is lateral. Well, gophers are going to be prevalent in this conversation. Like I said, my interest in this is longstanding. My very first project I worked on in archaeology where I got to do geoarchaeology was on a Mima mound project. It was a typical CRM project. I was kicked into the field and basically told, you're going to go work on the site. There's some mounds there. If you can figure out how they were formed, that'd be really good. And I didn't have a chance to go to the library, knew nothing about them. And you can imagine how I felt when I got back from the field, went to the library and found this voluminous literature on these features, which would have been really nice to know a little bit of something about before I went to the field. But I got kind of drawn into the literature in terms of trying to understand them because they're enigmatic things. And so I started looking into them, and what I found is that ultimately was that the toolkit that I had in terms of being able to try to understand them and take them apart was inadequate to come to any kind of resolution about how they were being formed. The approach I took at the time was I started looking into mounds that had been observed forming recently. And the reason I went that way was, okay, people had argued in a lot of cases when they're sandy, as a lot of them are in Texas, is people argue they're sand dunes. Specifically, they're coppice dunes, a type of dune that forms around vegetation. And so basically a plant grows up, the plant slows down the wind, it causes the wind to drop out whatever sand is being transported in it. And so a pile of sand accumulates around that piece of vegetation. In Texas today, you can find coppice dunes all over the area around El Paso that form around mesquite trees. And so I thought, well, okay, if we've got reports of these things having been formed in Texas, then I can go and look and see where these areas are. It was kind of weird to me to find that of the 3 cases of mounds that had been described forming in the historic period in Texas, two of the 3 were in one county, Colorado County. And it was kind of strange to me. So I went and looked in some of these areas, and one of them was a mound that formed under a house in a period of 17 years. House was built in 1900. In 1917, the floorboards were rotting in one of the rooms. So they went to replace the floorboards and were a little surprised to find that the ground had come up to meet the floorboards. The house was still level. The house hadn't sunk. The ground came up. Needless to say, that's not a sand dune. And the other one was a gentleman who was doing a master's degree at the University of Chicago. And he was a petroleum geologist, and every day he walked about 5 miles across the coastal prairie. And in doing, he reported on this for his master's thesis. And what he described was how gophers would push up a pile of dirt, cattle would come over and kick it around some, but progressively through time, a mound formed where they were living. He also noted that when they came out and they leveled this land for rice agriculture, the gophers abandoned their mounds, and which had largely been leveled, and went to live in the levees that were created in the rice paddies. So he sort of was arguing they're trying to get their feet out of the water, more or less. Anyway, I got attracted and enticed into playing with these things, and but it kind of was a dead end because I could never clearly get much resolution on it. But in the last year, I've worked on 2 projects that looked at these features. And so I want to talk a little bit about these 2. I just find it strange that I worked on 2 Mima mounds in the last year and didn't see them for the most part, almost entirely in the last 25. One of these was a project on Clear Creek that was done for a company called Swift River. This was 41 HR 161. That's a project that's complete. So we've actually done all the analysis on it, and I can kind of report what we saw. The other one is a project that's ongoing. This is work that's being done by AR Consultants at Bodark Reservoir in Fannin County. And I'm going to talk about one site there, FN 120. But everything I'm going to talk about on this is based on field impressions because we're still in the field and we've done no post-excavation work at all. So the first one I'll talk about is HR 161. And this is now in the city of Pearland. It's southeast of Houston proper, where the red square is on that map. And the mound that we're going to look at was actually recorded in early 1970s by Paul McGuff on Clear Creek. And in this landscape, McGuff noted that Pimple mounds occurred in 2 places. They occurred in the uplands, and they occurred also down on the valley floor of Clear Creek. And this is what this landscape looks like in the 1940s, right about the time that they're channelizing Clear Creek. You'll notice that Clear Creek is surrounded by a woodland, and you'll also notice that the upland is coastal prairie. And all those little white dots you see in the prairie are Mima mounds. And but their mounds are in both of these settings. Now, so I'm going to talk about 2 points here that kind of caught my attention in working on this project. One of which is the age of some of these mounds, and this may be my own personal problem, but I was kind of struck by some of the stuff that McGuff recited from what he found on their survey. And the other one is about what is the implication of the vegetation change that may have occurred here. This is one of the things that we saw in some of the data we generated from analysis of the site. But first off, talking about some of the mounds that had been found by McGuff and Cox when they did their survey. But also an antecedent, Bill Dickens, who was an archaeologist who did his PhD at Texas A&M. He published a thing in 1987 on a site in a Mima mound that was probably one of the ones that was found by McGuff and Cox, that he described a substantial Paleoindian assemblage in this. Now, when we talk about sites in these mounds, there's not much cultural material off the mound. It's restricted to the mound. And so the implication is fairly straightforward. If it's differential erosion, if it's basically was an occupation on a flat surface and then it's been let down by erosion, we kind of expect a scatter of artifacts to be all over the place. But these artifacts are restricted to the topography that's there. And a lot of these mounds in McGuff's and Cox's survey on Clear Creek reported an item or 2 of older artifacts in amongst a late prehistoric assemblage. But the thing that Bill Dickens reported and was also described by McGuff and Cox is a site that was predominantly a Paleoindian assemblage, which sort of slaps me in the face to recognize that these rather unimpressive widespread landforms could actually be quite ancient, more than 10,000 years old, and possibly much, much older than 10,000 years, which is, I guess, because I came at this from looking at how do they form now, it's kind of weird to think that they're actually really quite ancient landforms. So that was one takeaway. The other one was when we were looking at HR 161, we looked at a variety of different things to try and understand how the site had changed through time and what was the context and integrity of the archaeology within the mound. One of the things that we looked at, it was the distribution of artifacts, large and small, within the mound, and the sequence of temporally diagnostic artifacts and the age of charcoal and things within it. And the impression one gets from the artifacts of this mound is it's largely pretty much messed up. It's pretty well scrambled. But the other thing that came out of this is we looked at the composition of the stable isotopic material of carbon in the organic carbon in the soils. And this is a way of trying to get a proxy record for how has the vegetation changed through time. And that's the curve on the right panel on the side of this illustration. And what it showed is that the core of the mound actually shows evidence of having been formed during a period when the vegetation was grassland or mixed grassland and woodland. But at the top today, it's all forest. And so sometime in the not too distant past, it's hard to say from our data that we generated the site when this change occurred, but this landscape changed from grassland to forest. So it changed from a condition where it would have been favorable to the formation of Mima mounds, a landscape that was favorable to gophers, to one that is not favorable to gophers, and thereby so it changed the kind of things that are messing with the dirt. Looking into the pollen records in the Houston area, there was a pollen study that was done in Galveston Bay, and they noted that there has been a significant shift in increase in woodland in the landscape in the last 2,000 years. And I suspect, as I'd seen in some places like in Florida, that these woodlands are probably migrating up the stream valleys in the last 2,000 years. The impression I got from how scrambled HR 161 looks is that this is probably a very recent migration in terms of where that site is, but we really don't have any good evidence of when exactly that happened. So anyway, so this is a site that, you know, the mound, the early stage of the mound looks like it was grassland, and the context of the material in it is pretty bad, but it has recently changed to forest. And now, instead of having gophers all over the place, the main thing that was happening on this was the action of small animals and tree throws. A lot of trees would grow in this landscape, and they are not deeply rooted, and they tip over and they move around dirt that way. So, so basically summarizing that right there is, so what are the implications for integrity? Well, no more gophers in this landscape, at least in the riparian woodland. So if you actually have really late sites, the chances are the integrity of these sites would be very different from anything that was like any of these sites that are on the upland that are shown there, which are all still in grassland, although that's now all subdivisions. So they're no longer Mima mounds either. Anyway, the second project I want to talk about is Bodark Reservoir, and this is work that's ongoing right now. And I'm going to particularly talk about one site. This is 41 FN 120. FN 120 occupies a small remnant of a Pleistocene terrace that juts out into the valley of Bodark Creek. It's right in the very middle of the slide here. All those little red dots are excavation units on the site. And the site is covered by small Mima mounds. They're really small. But you can look to the left of all the red dots, and you can see the next higher up surface is just covered with really good sized Mima mounds. All of this was recently clear cut in the not too distant past in the historic period. This is a map that's derived from LiDAR imagery. Gus Costa put this together. He also did this one, which I kind of really like. It kind of shows the Mima mounds kind of in a ghost-like form. It's very evocative. It's kind of hard to see the ones that are actually on the site, but the ones that are upslope that are really prominent show up very, very nicely. So, like I said, FN 120 was pretty much has been forested up until it was excavated, and yet it's covered by Mima mounds, which sort of raises a question. If these are features that are forming in grasslands by gophers, when was this last a grassland? Now, if you look at the pollen records for a lot of East Texas, now think of this as not just this one site. There are woodlands all over East Texas. What is the hallmark of East Texas? It's dominantly woodland, yet it's covered with Mima mounds. And so the question is, when were these mounds actually forming? How many tens of thousands of years ago was it actually grassland enough to actually allow these gophers to run rampant and do their thing? And so when we first got to the site, my presumption was that based on other Mima mound sites that I'd looked at, in the context of the cultural material inside of it is going to be pretty poor, because most of these sites are pretty heavily disturbed by rodents. FN 120 is not like that. FN 120 was a very big surprise. These mounds at this site appear to retain relatively good stratigraphic integrity, which begs the question, why? How does that happen? So if, just to give you a, you all seen the evidence of what gophers do to our profiles, but this is from today in the field on a site this is in a Mima mound, a different site. And this is at Bodark Reservoir. It's FN 244. And this is a photograph of a profile that's been molested by pocket gophers. And Gus was playing around with the rock art tool D-Stretch, which some of you may be familiar with. So if you want the psychedelic alternative view of this, you can go look at it that way, which really brings out that the red material and the orange material is the subsoil being brought up entire into the profile by gophers and worms, and the darker material above is the lighter, sandier stuff in the profile. But really going back and forth, you can't really see how much the red material is there, but D-Stretch really draws it out very nicely. But that's what the gophers do to it, and that's a pretty scrambled site. But this is a photograph of one of the profiles from one of the Mima mounds at FN 120. And I'm going to draw your attention to a couple of things here. One is, if you look in the top right, there's above the yellow line is a deposit that's kind of got a bunch of little clod looking things in it. That was actually, whoops, wrong one. That was actually disturbed by a backhoe trench. So ignore that part. But in the middle of the profile, in between the two red lines, is a matrix. It's a dark body of matrix. It's probably charcoal enriched soil. And this is what I would refer to as a matrix defined feature. Now, the retention or creation of matrix defined features in an environment that's dominantly inhabited by bioturbating animals is, to me, kind of a paradox, because they seem like they're immiscible. They shouldn't exist together. But it really comes down to what animals are doing the bioturbation. Now, you can see in the left side of the upper left of that profile, all those holes. Well, that's an ant gallery. And you can notice that how the deposit close to the surface is pretty homogeneous. That's mostly spoil taken to the surface by ants, probably from that one colony. But one of the things that was very prevalent at the site is, although there were no gophers, there was almost no evidence of gopher bioturbation. We saw lots of evidence of small animals doing things. Ants, and this is the size of the ants that are moving things, they're moving particles up to about 3 to 4 millimeters. So these are some pretty healthy red ants. But the other one were these guys, and you may have seen these things, but most people, this flies under most people's radar. These things in the picture on the right there are surface casts created and put on the surface by earthworms. And earthworms, like ants, can only move things that are pretty small. And so as a result, when they move dirt around in the subsurface, they can't move the big artifacts. And so what they end up doing is they end up burying the artifacts, but they retain this relative stratigraphic sequence of the site. And so as a result, the worms actually preserve the stratigraphic integrity of the site. When we first got out there, I had no idea that that was going to be one of the driving forces on the site, but it was kind of a shock to see that probably was what was going on. Oh, the other thing I was going to go back to is in this photograph is that, okay, so you're talking about, you're on a Mima mound. This Mima mound is jutting out into an alluvial valley. We thought at first that maybe this could be getting buried by alluvium. So we dug trenches on either side of this Pleistocene terrace, and the modern alluvium doesn't even get up onto this landform. So these aren't getting flooded and buried by alluvium. And these mounds are the highest topography, the highest pieces of ground on this landform. Yet the archaeology is getting buried. And it's in a forest. So it's not windblown sand. It's not even sand, it's silt. So you have to ask yourself, how are these things getting buried in this environment when they're the highest piece of local ground? It's not water that's doing it. And I think the inescapable conclusion on this kind of thing is it's got to be insects and worms. Now you're starting to go, yeah, right. you're telling us worms are doing all this great stuff. Well, I hate to tell you this, but the first sum that was written about worms and their effect on soil was by a guy you've probably heard of, none other than Charles Darwin, who wrote an entire tome on this back in the 1880s. It actually initially outsold Origin of Species. Hard to believe, but yes, true. And Darwin actually wrote this book because he had noticed that he had left some things in his back garden, and when he came back a couple of years later, they were gone. And he was like, well, I didn't move them. Where did they go? And that's when he found out that the worms were burying them. And so it was he did a lot of study of what the worms do, what their habits were, and especially their tendency to take dirt to the surface, a process we call bioexhumation. How fast can this happen? Well, Darwin noted that they were, burying things in a relatively short order, and studies have been done after Darwin. Is what they found is things got buried to a reasonable depth, 10 to 15 centimeters, relatively quickly, and then they slowly didn't get any deeper or not much deeper. I had one project back in the early 90s where I had a chance to kind of play with this. I wasn't anticipating looking at worms, but I worked on a site that was called the Leon River Medicine Wheel at Fort Hood. To this day, it's the only project in my repertoire that if you Google it, it shows up on a website called Unsolved Mysteries, which is kind of bizarre all by itself. And but this was a presumably Native American medicine wheel, which is a small cobble stone alignment feature. And after my remit was to try and understand the eastern, if you can look at the image on this, which is the cover of the report, you can see the little black dots on the left side are the actual stones that make up this stone alignment, and they're not present on the east side, on the right side of the diagram. And so my remit was, is this thing buried or is it just not there? Well, it wasn't there is what we concluded. But I was trying to figure out what was possibly burying this. And so I went through everything I could to understand what could possibly be burying it. And we were doing this excavation in spring. And one of the things that jumped to attention as I was just working out there is it would rain every other day or so. is how much the worms were throwing on the surface. And so, but I was like, I couldn't find much evidence in the information in the literature about how fast worms do this. So then I resorted to the kind of stuff that you guys probably know me for, is doing really weird, strange things. So I took 2 1-meter squares, took off all the vegetation, and then every morning I'd come out with a set of paper envelopes and I would collect the worm casts from every worm that dumped dirt on the surface overnight. And then I would take them back to the lab, I'd dry them, weigh them, and then most importantly, I would drop them into a graduated cylinder with water so I could measure their volume and figure out how much volume they represented. And then I started making estimates of how fast worms can put stuff on the surface. I tried to make this a conservative estimate. And then when I say conservative, I know the worms don't do this every day. They don't do it all during the year. We know from, when you look at Darwin's work and other work that's done more recently, worms aren't real active in the winter. They're not real active in the middle of the summer. So the kind of spring and the fall are kind of the period of time they really are going to town. And so I made an assumption that they only did this after a certain amount of rainfall, and it's just a very conservative estimate. And what I found was that at that site, the worms could account for the burial, all about just the worms, not even counting the ants, could account for the degree of burial of these that we saw on the rocks within a period of 40 years. And equates to something in the order of about 7 to about 13 centimeters of dirt added to a 1 meter square in a century. Think about that one for a while. How do our sites get buried? Well, some of them are getting buried by little critters doing stuff like this. If you look into the more obtuse scientific literature on this, Don Johnson, who was one of my favorite authors on this type of subject, who was the author of my favorite jargonated article title, which is the one at the bottom there, is the pro-isotropic and pro-anisotropic processes of pedoturbation. Repeat that now fast 3 times. It's a really obnoxious title, and you really have to work to understand it. What he's basically saying is he's looking at processes that promote isotropism, homogeneity, and processes that promote stratification or anisotropy. But what he was really talking about, in less obnoxious verbiage than the title of the paper, was how animals mess up your dirt, but it depends on how big the animal is and how big the particles are in your dirt. And so this little graphic on the right side, so on the left part of it in 1, he basically says, and if you have an unstratified paramaterial that's got big stuff and little stuff in the top, and you have little things like ants, termites, and whatever mess with it, what happens is they move the stuff they can move, and the big things seem to sink in the profile. And so you get a stone zone at the bottom, or a relative concentration of bigger things down lower in the profile. You can do the same thing with gophers. Gophers, if you look at the literature on what gophers do, they will move anything that is as big a diameter as they are. And if it's bigger than them, they go under it. And so for the most part, the really big stuff will sink with gophers, but the gophers tend to homogenize a much broader range of particle sizes. You can contextualize that as meaning our artifact assemblages. So they tend to blend most of our artifact assemblages very nicely. So anyway, who disturbs your deposit does matter as to how badly they mess up our archaeology. But what I had never really thought about was how pedoturbation by these animals is reliant upon the vegetation. Gophers like grasslands in open environments, and they're prevalent, they're the dominant places they live. If you have a place that's, so like in the case of Mima Mounds, if they're being created by gophers and they're being formed in grasslands, once these landscapes turn into forest, like they are in East Texas, like at FN 120 and at HR 161, that means those landforms are, 1, now relict. They're not forming anymore. And so the things that created the landform aren't doing it anymore. It also means that the animals that disturb our profiles have changed from things that really mess up the archaeology to things that actually preserve our archaeology, relatively speaking. And I had never really thought about this being a temporally and spatially dynamic kind of process. And I thought that was really kind of mind-boggling, to say the least. I'm still kind of trying to get my head around it, because I don't think many of us can actually say, well, when we get out into a site, what was the vegetation here 5,000 years ago? We generally have no idea. But it's when you start looking at how the archaeology is being preserved, it's one of the things that's obviously conditioning it. So I'm starting to think that not all sites that are in Mima Mounds are messed up. In fact, I think it's pretty clear now that it really depends on what is the history of those landforms. If they're Mima Mounds that are in forest settings, chances are you may actually have pretty good integrity, which was kind of a real shock to me. I'm really looking forward to doing some of the post-excavation analytical work on this to kind of try and tease out some of the subtleties of this to see if these are as intact as they appear, or are they more messed up and it's just at a small scale that they're messed up. But yeah, and so, mounds and grasslands, if you have archaeological sites that are in mounds that are in grasslands, yeah, chances are they're still experiencing rodent bioturbation, and they probably don't have very good contextual integrity. But if you have mounds in forest that are now relict and they're experiencing bioturbation by mostly small animals, tree throws, which do happen in these environments, can seriously mess up your soil profiles. But the stuff that's being done by the animals is relatively benign. And that's just kind of strange. So these mounds are ancient landforms. That's kind of weird all by itself. I think some of these landforms may be tens of thousands of years. When I say tens of, maybe 50, 60,000 years old, which is really, to me, kind of mind-boggling all in and of itself. They're old enough to have Paleoindian occupations and people choosing that landform for settlement throughout the entire Holocene. And the other question it just brings me back to is, when was East Texas last a grassland? I really have no idea, but it's a long time ago. And that's probably when a lot of the Mima mounds formed. Okay, and I will stop there.